Okay, so at the top of your paper here. No. All right. So girls, I'm really trying to get through this. All right. Same thing over there. Right. I just want to get through the work. All right. Now we have, yesterday we talked about parallel lines and a transversal. I'm going to show you how that kind of relates today for a triangle and how they calculated or how they were able to come up with why a triangle's angles always add up to the same thing. I will try to demonstrate that. Yes, that's correct. All right. You guys should know that. It's something you've learned. The angles of a triangle always add up to 180, but there's classification of triangles. All right. You classify them by angles and you classify them by sides. All right. So at the top of your paper, all right, what I'd like for you to do is I would like for you to try to draw an equilateral triangle. All right. And if you have an equilateral triangle, all the sides are what? The same. That's why they call it equilateral. All right, so everybody needs to call it equilateral. That's classifying it by the sides. All right, then what I'd like everybody to do is I'd like you to draw a triangle with two sides that are equal. So remember what that's called?
Non-equal. And like it starts with an I feel like.
Yes, it does. All right.
It's like it's a weird word. Yeah.
Well, it's not really too weird, but it's yes, very smart. I know. See, some of you guys insist on talking, and I feel like I don't need to get upset. Or I don't want to hurt your feelings. All right. I'm not interested in what you're having a conversation about. Keep it up, girls. Your feelings are going to get hurt. This is isosceles. All right. This is isosceles. Now, the technical definition of isosceles is at least two sides are equal. At least two sides are equal, but I am not going to hold you to that. So when someone says equilateral, you could also say, haha, that's not only equilateral, it's also called what? Yes, but again, no one says that's isosceles and it's equilateral. All right, no one does that. All right, so I'm going to ask you specifically, if all three sides, you're going to say it's equilateral. If two sides are going to be called isosceles, and then all I need you to do is draw a triangle that has no sides that are equal. And if no sides are equal, remember what that's called from last year. Tell us. Good. That's close. Obtuse has to do with the angle measure, though. This is
it starts with an O.
Scalene. All right. So scalene means no sides are equal. Scalene means no sides are equal. Now, how do you determine how or if the sides are equal? They're the little tick marks that you put on there. So if you have a triangle with 3 tick marks and they're the same number of tick marks, that means all sides are equal. All right. So you have equilateral, all 3 sides, isosceles, and scalene. That is how you classify it by its sides. All right. Now, if you're going to classify it by its angles, all right, you have a choice. All right. In this, all right, we say all of the angles are what? Less than 90. So that's called an acute triangle. Acute. All right. All angles are less than 90 degrees. It is considered acute. All right. Now, can isosceles be acute or obtuse? All right. So let me see if I can make a quick little demonstration here. That is a what? Isosceles obtuse. All right. This one up here is isosceles what? Acute. All right. This down here would be considered isosceles obtuse. And obtuse meaning what? Greater than 90. Good job. Acute means what? Less than 90. Okay, we're on the same page. All right. So you can have an acute triangle, all angles are less than 90. You can have an obtuse, which just means one angle is greater than 90. And then your other option is what? To classify. Right, there you go. So now I'd like everybody to draw a right triangle. Now, how do I know that's a right triangle? Because there's a box in the corner. That's correct. Now, that would be considered a scalene right triangle. All right. Now, let's draw an isosceles right triangle. Because no sides are equal. How do I know no sides are equal?
Oh, because there's no tick mark.
There's no tick marks. Thank you very much. All right.
So that's how you show.
Because if you would measure them, they would not be equal. All right. Now, do I know that's an isosceles right triangle yet? No. First of all, there's no angle that's marked 90 degrees. Now, is it a right triangle? Yes. Now, is it an isosceles right?
Yeah.
Yes. It is an isosceles right triangle because the angle is 90 degrees and the two sides are congruent. Now, somebody quickly draw me a equilateral right triangle. An equilateral right triangle. Everybody draw that real quick. Equilateral right triangle. So all of you that were proud of yourselves for drawing an equilateral right triangle, it's not possible. It's not possible. Listen to what I'm saying. Just stop arguing, stop talking so we can get done. All right. You cannot draw a equilateral right triangle. You cannot do that. All right. First of all, if it was equilateral, that means all of the angles would be the same. All right. And if you have a right triangle, you can't have three 90-degree angles. All right. Now, what I'd like to do is I'd like to really quickly demonstrate to you how they figured out that the angles of a triangle add up to 180 degrees. All right. So everybody take a look at this real quick. You don't have to write any of this down. I'm just trying to make you smarter. All right. So everybody's looking up on the board. This is parallel to this. Does everybody agree with this? All right. Now watch. I'm going to cut a transversal from here to here. All right. Then I'm going to draw another transversal. All right. Like I said, you don't have to draw any of this. Just look up on the board. Here is another transversal. All right. Now what I'm interested in is I'm interested in this triangle right here that was formed. So everybody stay with me. This triangle right here, this triangle right here, and this triangle right there. So everybody with me on that? That's the triangle we're looking at. So I can try to demonstrate to you how I know that the angles of a triangle add up to 180 degrees. All right. The first thing I want everybody to recall is this right here has how many degrees? That straight line has how many degrees? 180. Thank you for saying that. All right. Now, for those of you guys who are not sure, I'm just going to draw a circle. Who created the 360 degrees in a circle? Yes, the Babylonians did. Very smart. The Babylonians did. Now, all the way around the circle is 360 degrees. So halfway around the circle is 180. That's how we know that a line has 180 degrees. All right. It was something that was completely made up, 180 degrees. So I want to ask you a quick question here. Now, look up so you can be smart. Look here. This from here to here is how many degrees?
180.
180 degrees. Keep that in mind. All right, that's 180 degrees. All right. Now, I want someone, I'm going to erase that last step. I want someone to tell me this measure of this angle right here and the measure of this angle right here. What's true about those two angles?
They're both acute.
They are congruent. Why do we say they were congruent? Because yesterday we learned they are alternate interior angles. So I want everybody to look at this right here. This will be your first proof. This right here, this is what we do in geometry. That right there is equal to that right there. Does everybody agree with that? Right? Now what I'm going to do is I'm going to come over here and I'm going to mark this figure. Come on, stay with me. This angle right here is congruent to what angle?
The other one on the other side.
That's right. Very smart. Is equal to this angle right there. Does everybody agree with that? All right. Now that red and that green. All right. Now I'm going to highlight this piece right here. This angle right there. What do those three angles add up to?
180.
180. So I'm trying to show you now. Look at this. A red plus a blue plus a green add up to what? How many degrees? 180 degrees. Everybody looking up? Come on, come on, come on. Try to be smart, guys. You don't have to write it down. Right? Does everybody see that?
Because now there's a red and a green.
Now you're supposed to look at the triangle only. You just showed me that a red plus a blue plus a green is equal to 180 degrees. Everybody see that?
Yeah.
So now look at the angles in the triangle. The angles in the triangle have a what? A red, a blue, and a green. So because they have a red, a blue, and a green, they must all three add up to what? 180. All right. That's the beauty of geometry. All right. You are able to prove things. It's really a fascinating class. Yes.
So that simple that you just showed us that equals to 180. That's good.
Well, the reason I was saying I was reviewing this piece of the puzzle because someone once asked me, how do they know it's 360 degrees? And to be perfectly honest, I had forgotten from my college days. So I had to go back and do some research. And it was strictly the Babylonians who came back and said, we're just going to make a circle have 360 degrees. And then you're supposed to look at a line and you're supposed to say, well, a line is just half the circle. So the line has to be 180 degrees. You with me on that? All right. So that's something, hopefully, all right, that when you take geometry and they ask you to prove the angles of a triangle add up to 180 degrees, that will be no difficult thing for you. But for most people, they have no idea why the angles of a triangle add up to 180 degrees. All right. With that being said, I have done everything I can do for you today. So now we'd like to get through the homework. All right. So we will start over at Wyatt today. All right. First thing I need you to do is calculate. You can use your calculator. I need everybody to calculate what X is. Wyatt's going to start us off. How do I figure out what X is here, Wyatt? Oh, no, don't say that to me. Stop talking. The angles of a triangle add up to how much? 180. So how much do we have so far? Okay, then what? Yes, you add these two angles up. And then you subtract from 180. So those two angles add up to 131. And then it's just 180 minus 131, which tells me that's what? He said 49. Now stop talking for a minute. All right, so now I have all of the angles. Notice all of the angles are different, correct? So if all of the angles are different, if I classify it by its sides, it would have to be what? Now your choices are at the top of your paper. It's equilateral, isosceles, or scalene. Scalene. All right. Now what you do is you look at the angles. All of the angles are less than what? So it must be what? Come on. It's scalene and acute, and X equals 49. That's what we're doing. All right, number 2. All right. Mr. Walczak, what is X? Yeah, this is 90 degrees, but X is not 135 degrees. What would that be?
45.
Stop talking. 45 degrees. Perfect. All right. Now look at the sides. How many sides are equal? So it's called what? It is called isosceles. ISOSCELES. All right. Now the angles. Bless you. What type of angle is this? What does something that it's equal to 90, correct? So it's called a what? No. It's a right triangle. It's a right angle. So you're classifying by the sides and the angle. If one angle is 90, then it's considered right. If one angle is greater than 90, it's obtuse. If they're all less than 90, it's called acute. And these are what I'm saying are on the ERBs that it should be kind of easy. All right, but we forgot the definition, so we're helping you out right now. All right, number 3, let's go. Calculate what number 3 is. Finley, what's X?
$37.
37 degrees is correct. So now classify by sides and angles. What's it going to be called? Scalene is good. No. No, you're right, because 107 is greater than 90. All right. So all it has to be is one angle greater than 90, and it's classified as obtuse. If all of them are less, it's acute. All right, and these are the things I'm glad you're making little mistakes on, right? Because we're correcting it. All right, anybody have any trouble with number 3? All right, Quinn, you're up. Number 4. So X is 60. Equilateral, thank you. Equilateral, and it's acute. Exactly. Equilateral and acute. All right, Mr. Williams, you're up, buddy. Good. Yes, sir. 55 degrees. So now classify it. Why is it obtuse? Acute, thank you. Are any sides the same? Scalene. Nice. All right, number 6, Dave, you're up.
Okay. 48 plus 75. And 180 minus 123.
Right?
That's 57.
57. So now what type of triangle do we have?
Scalene.
Scalene.
It's acute.
Scalene. Acute. Scalene and acute. All right, I'm good with that. All right. Lena, go.
X is 74.
How did you get that?
E2 plus 24 is 106.
Exactly.
80 minus 106 is 74.
So this angle right here is 74 degrees. That is perfect. Wait a minute. What's X though? No. Now watch me. How many degrees from here to here? How many degrees from here to here? Nope. Well, I mean, yes. The blue right now is 180. X, though, you said it correctly, was how much again? What's this from here to here? No, this is 74. Yes, 106 is X. You with me? All right, so the outside angle is 106. All right, now classify the triangle. The triangle is considered what? Acute, and what else? Scalene, that is correct. Acute and scalene. Is that all right? All right, anybody have any questions with that? All right, here we go. Number 8. Now, what I want to do is, I want you to tell me this angle right here is 25, correct? All right, so now all 3 angles have to add up to what? So, who's up on this one? All right. So listen to me, guys. I don't really care about the X plus 5. All right, just tell me what the angle measure is there. I don't care about that. 65. Is everybody okay with that? 65 degrees. Anybody have any issues? So now what type of triangle is that? I'm agreeing it's scalene. Why do you think it's obtuse? What does 90 mean though? Yeah, it's a right angle. Therefore, it is a right triangle. But you're supposed to know they tell you it's 90. So as soon as you see 90, you're automatically knowing, all right, that it's right. Okay, let's take a look at number 9. What do you think on number 9, Carolyn? Yeah, we don't have to know the measures. We just have to tell me what do you think it is? That's exactly correct. Scalene and right. Perfect. Next. Definitely isosceles. Thank you very much. Yes, but how do we know what this angle is? Calculate that for me, though. Yeah, I'm agreeing with you. So you're correct. It's isosceles. And acute. Isosceles acute. Very good. All right, number 11. Let's take a look at this wing of the plane. All right. I like scalene. Scalene in what? Why do you think it's acute? What's the measure of the missing angle?
Oh,
120. So now it's going to be scalene and what? Scalene and obtuse. That is correct. Scalene and obtuse. Okay, I want everybody to look at number 18, please. Everybody's on 18. So the measure of an angle of a triangle are in the ratio of 5, 6 to 9. So here's what I want everybody to try. All right, everybody's going to draw a triangle. All right, everybody draw a triangle for me. And it says the angles are in a ratio of 5 to 6 to 9. All right, I'm not expecting you to know how to do that, but I am expecting you to pay attention. And if something's in a ratio of 5 to 6 to 9, instead of writing 5, 6, and 9, I want everyone to write 5x. What about right? 5x, 6x, and 9x. 5x, 6x, and 9x. All right. So how many x's do we have all together? Someone? How many x's do we have all together? Nope.
6.
Right, who said that? Good job. How did you get that? Right, 5x, everybody write that down, plus 9x plus 11x. That must equal how many degrees? All those angles have to add up to how many? Well, but I'm saying, yeah, I don't know what my,
Should we put the X in parentheses?
no, don't do anything. Just write it just like I'm showing you. 5x plus 9x plus 6x. All those angles add up to what number?
180.
180. Thank you. All right, now as he stated, 5x plus 9x plus 6x adds up to what? 20x. 20x equals 180. So if 20x equals 180, x must have been what? Come on.
Oh,
If 20 times x is 180, x must have been what?
no.
9. Very smart. 180 divided by 20 is 9. You divide both sides by 9. All right. Divide both sides. Now, here's the tough part. So what's the measure of this angle right here, guys? 45 degrees. That is correct. How did you know that? Times it by 9. Whoever said that, thank you. What's the measure of this angle up here? 81 degrees. And what's the measure of this angle right here? What is it? 54 degrees. There you have it. All right, so now you can do number 19 because 19 is the same as what? 18. Draw it out for me. All right, I think that's everything now. All right, you guys can do the rest of that. All right, I just checked through it real quick. It's not a big deal. All right, you guys can knock that out. All right, we get out at what time? Yeah, 4 minutes. Come on, 4 minutes. Try. You guys are good enough. Some of you are good enough, quick enough.